In this video, let us solve the numerical problems set 3. The first problem is compute THOD, theoretical oxygen demand of 108.75 milligram per liter of glucose. It is C6H12O6. So theoretical oxygen is basically the stoichiometric oxygen demand based on chemical formula. So write the stoichiometric equation C6H12O6 to convert this into CO2 and H2O by oxygen is 6CO2 plus 6H2. So we know here the C6H12O6 molecular weight, which is 180 grams per mole. Then this 180 grams consumes 6 moles, that is 192 grams. 180 grams of C6H12O6 consumes 192 grams of oxygen. And we are asked to calculate for 108.75 milligrams how much oxygen would be required. So it would be 108.75 into 192 by 180. This would be 116 milligram per liter. Next question. If 3-day BOD of water is 75 milligram per liter and BOD constant, decay constant, K is equal to 0.345 day inverse, what is ultimate BOD? So these are all direct application of the formula. So we have the formula BOD at any time is equal to ultimate BOD L0 into 1 minus e power minus KT. So we want to calculate this L0, so L0 would be LT by 1 minus e power minus KT. LT value is given at time 3 days, that is 75 divided by 1 minus e power minus K value is 0.345 into days would be 3. So you compute, you will get 16 milligram per liter. Next question. The BOD 5 of wastewater is 150 milligram per liter at 20 degrees Celsius. So this question is on temperature effect. So the K value is known to be 0.23 per day. What would be BOD 8 if test were run at 15 degrees Celsius, given KT is equal to 0.23 into 1.047. Okay, so the temperature influence on decay constant is given. So first, the common thing at different temperatures, whether it is 20 degrees Celsius or 15 degrees Celsius is the ultimate BOD. So first calculate ultimate BOD LT, which would be LT, L0 is LT by KT. So the ultimate BOD for the case of 5, L5 by, because we are given with the BOD 5 initially, so minus 0.23 into 5. So this value is 150. So if you compute this, you get around 220 milligram per liter. So now given the ultimate BOD, and you have to calculate K at different temperature. K at 15. K at 15 would be K at 20 into theta, that is 1.047 T minus 20. K20 is 0.23 into 1.047 given minus 5. So this would be around 0.18. Then now to calculate L8, we just L0 into 1 power m minus kt. L0 value is 220 into 1 minus e power minus k at 15 is 0.18 into 8 after 8 days. This is 168 milligram per liter. So next question. The dissolved oxygen in an unseeded sample of diluted wastewater having an initial DO of 9 milligram per liter is measured to be 3 milligram per liter after 5 days. So initially the water sample dissolved oxygen is 9 milligram per liter. After 5 days it becomes 3 milligram per liter. The dilution fraction is 0.03 and reaction, or you can say decay rate K is 0.22 day inverse. Calculate a BOD5 B ultimate BOD L0 C what would be the remaining oxygen after 5 days. Remaining oxygen after 5 days. L0 is the total oxygen. Then what after consumption of BOD5, the difference between L0 and BOD5 would be the remaining oxygen. Okay. So to calculate L5 BOD5, the formula is initial DO minus final DO by the dilution fraction. That is initial DO is 9 minus 3 by dilution fraction is 0.03. So you get around 200 milligram per liter. Then we have now L5. We can calculate ultimate BOD. Ultimate BOD L0 is L5. Just now we have done minus KT L5 is 200 divided by 1 minus e power minus 5 into k, 5 days t into k is 0.22. So this would come around 300 milligram per liter. So total BOD is 300, out of which BOD which is consumed is 200. So the difference, okay, would be remaining is 300 minus 200, that would be 100 milligram per liter. Next problem, BOD dilution. 6 ml of wastewater diluted by factor, instead of fraction here factor is given, factor 50 using distilled water. Initial DO is 8.5 milligram per liter, and after 5 days DO is 5 milligram per liter. Determine BOD 5 of wastewater and ultimate BOD. Given the K value is 0.23 day inverse. So it's a direct problem, just the difference is here factor is given instead of fraction. So L5 would be initial DO minus final DO into dilution factor. Initial DO is 8.5 minus final DO is 5.0 to dilution factor is 50. So this gives 175 milligram per liter. Then L0 would be L5 by 1 minus e power 5k. So that is L5 is 175 divided by minus 5 into k value is 0.23. So this is 256 milligram per liter. So that's it, the numerical problems 3. I will discuss the next set in next video.